In this lesson, we're going to learn how to create a generic interface that can then be implemented by other classes. So let's get started. We're going to keep working with the concept of lists, and this time we're going to create a list interface so that we can create different types of lists. So we're going to call this program ilist.java. So we begin our interface by writing public interface ilist, followed by our placeholder for our type. We're going to make this a minimal interface. So we'll start out with a void add method, which takes a t element, since we don't know the type yet. And then we're going to have a tGet method that takes n as an argument and will return the nth element from our list. So like I said, this was going to be a minimal interface, so we're going to stop right there. So you see how the type placeholder is used very similarly to how we do it with a regular class. So let's exit and save. And let's compile our interface to make sure everything's all right. Now let's create a class that implements the interface. We're going to call this class numberlist.java. So we write public class numberlist t implements ilist t. The first thing we do is declare our fields. So we have data store, we have size, and we have position. Our constructor, initialize position to 0, and then initialize our array. And again, what we're doing here is we're creating a new object array and then casting it to the type that we want it to be when we declare the type at runtime. So our next step then is to implement the two methods that are part of the interface. So we'll start with add. Add is a void method that takes a t element, then we store the element at the current position of the array, and then we increment the position by 1 in order to move to the next free array position, and that's all that method has to do. Then we're going to implement the get method. So let's do that. Start at public tGet, and it takes a index position and returns the data at that position. So again, notice how we use the type placeholder in the appropriate place. Here we use it as the data type for the argument to add, and here we use it as the return type for the get method. Let's save our file, and let's compile it. And except for our warning about unchecked operations, everything, it looks just fine. Now, just for fun, let's use this definition to create yet another type of list. So I'm going to do a Control-C to copy, and we're going to close. And then let's create a string list class. All we have to do is change the name, and then save it. And we'll come back and compile. Copying and pasting always leads to problems. Should have done a find and replace. There we go. So we needed to change that number list to string list. Now let's try that again. And that time it works fine. I'm going to save a test of these classes that implement the ilist interface to the exercises. But I feel very confident that everything's going to work fine since our classes both compile without any problems. So let's take a look at the interface one more time. The interface is really nothing fancy. Let's do it like this. But again, it gives us the extra control that we want, provides us with a means of building on a hierarchy of objects, which is always a nice goal when you're doing object-oriented programming. And this shows that we can do it generically as well by creating a generic interface. So with that, we're going to leave class definitions for a while And now we're going to look in the next couple of lessons at how to create generic methods.